In this video, we're going to solve an inequality involving a fraction. When you solve inequality involving a fraction, you cannot use the same method as you solve equations involving a fraction. Especially, your denominator contains variable. The reason you cannot use the same method because when your denominator contains variable, you try to get rid of your denominator, then you say, can I multiply 1 minus x to both sides of the inequality? The answer is no. You cannot do that because you do not know 1 minus x actually is greater than 0 or less than 0. If 1 minus x is greater than 0, you multiply 1 minus x to both sides, and the inequality does not change direction. But if 1 minus x actually is less than 0, you multiply 1 minus x to both sides of the inequality, then the inequality is going to change direction. Since we do not know 1 minus x is greater than 0 or less than 0, so therefore we can't use the denominator to multiply both sides of the inequality. Then what are we going to do? When we solve this kind of inequality, we always make one side equal to 0. So for this case, what do? We want subtract 1 from both sides. So what do? We're going to have 1 plus x divided by 1 minus x minus 1 and greater than equal to 0. Subtract 1 from both sides. Then we combine these two terms together, so get a common denominator, which is 1 minus x. We write 1 as 1 minus x divided by 1 minus x. So now we combine these two fractions together. So we have 1 plus x minus 1 minus x, the whole thing, and make sure you put a parenthesis there, divided by 1 minus x, greater than equal to 0. So now, and you can see here, and you have 1 plus x minus 1 plus x. When you drop the parenthesis, because in front of the parenthesis you have a negative sign. When you drop the parenthesis, you're going to change the sign for every term. So negative 1 plus x divided by 1 minus x greater than equal to 0. So now 1 and negative 1 cancel out, so numerator becomes 2x, denominator 1 minus x. So we have a 2x divided by 1 minus x greater than equal to 0. So now how are we going to solve this? What we try to do to solve this, we're going to find the zeros of the numerator, the zeros of the denominator. So the zeros, which means make the numerator equal to 0. So you have a 2x equal to 0, so you find the x equal to 0. And the zeros of the denominator, which means you set the denominator equal to 0, so you find the x equal to 1. So therefore, we have these two numbers, x equal to 0, x equal to 1. We refer this number, normally we call this as the critical numbers. Okay, we call the critical numbers. Now what do we do next? What do we do next? We're going to use critical numbers to divide the number line into intervals. X equal to 0, so this is 0, x equal to 1, and 1. And now what we try to do here is to verify the inequality is greater than 0 or less than 0 in that interval, and this interval. And because what we know between two consecutive critical numbers, this will not change in sign. So which means if we know and one number in that interval and is greater than 0 or less than 0, make this inequality greater than 0 or less than 0, then we know that everything in that interval will make this greater than 0 or less than 0. Okay? So now, what we do here is we choose a number, and from negative infinity to 0, we choose, say, -1. Between 0 and 1, say we choose 1/2. And from 1 to infinity, say I choose 2. So now all I need to test if this -1 will make this greater than 0 or less than 0. So we put that in there. So we have 2 times -1 divided by 1 minus -1. So which is -2, and 1 minus -1, which is 2. This is -1 is less than 0. So which means here, this part is going to be negative. From 0 to 1, I choose 1/2. I got a 2 times 1/2, and 1 minus 1/2. So that is 1. That is 1/2. That gives us 2, which is greater than 0. So that's greater than 0. And finally, for this interval, I choose 2. So here, 2 times 2, 1 minus 2, and that gives us 4 divided by -1, which is less than 0. So therefore, that's less than 0. So from here, we can tell only in this interval between 0 and 1, and will make the inequality greater than or equal to 0. Okay, and only the number between 0 and 1 will make this inequality greater than or equal to 0. So therefore, the solution must be from 0 to 1. 0 to 1. And here, because when x equal to 0, that's numerator actually equal to 0. But since we have equal to 0, which is fine, so therefore here you're going to use bracket, means 0 is included. But for the 1, you can't. 1 minus 1 denominator equal to 0 is undefined. So therefore the 1 is not included. Therefore the solution will be from include 0 to 1. 1 is not included. That's how we solve inequality like this.